Hello everyone, welcome to my YouTube channel. Today we are going to discuss about topic sensory adaptation. So as you can see in the screen that here a lady comes to a cafe to drink coffee, and at the first day she senses the strong sense of coffee smell. So after visiting that coffee shop for several times, she is adapted to the smell of coffee. So, this is all about the sensory adaptation, which we are going to discuss in this video today. Sensory adaptation, when we define it, it is a psychological and biological phenomena where our sensory receptors become less responsive to a constant, unchanging stimulus over time. This results in a diminished perception or awareness of that stimulus. It's an automatic involuntary process that essentially helps brain filter out redundant or irrelevant information, allowing you to focus attention on a new or changing stimuli in the environment, which is crucial for survival. Even in your classroom, you have realized that when you are talking to your one of the closest friend, even though class is too noisy, you don't know about other thing because you are adapted to that classroom, that noise. So sensory adaptation, it's a psychological and biological phenomenon where our receptors become less responsive to a constant unchanging stimulus over time. So how it works? What are the examples of sensory adaptation? We are going to discuss this in this slide. So sensory adaptation occurs because the neural receptor cell that initially fire strongly when a new stimulus is detected begin to fire less frequently or stop firing altogether if the stimulus remains constant. So in the previous slide, I showed you a picture of a lady who went to a coffee shop. In the first days, she smelled coffee in very aromatic nature and it was very strong to her. But slowly, when she came there over time again, what happened? Her neural receptor began to fire less frequently or stop firing altogether, because of which stimulus remained constant. So this process occurs across our most of our senses. Number one is smell. So, olfactory adaptation. When we first enter to a bakery, the aroma of fresh bread might be intense. After a few minutes, we barely notice the smell because our olfactory receptor have adapted. Now, what we need to understand here is that in every home there is different smell, but the family who is living in that home does not sense it because of the olfactory adaptation. But if a new guest comes to that home, they feel the different smell. So it is because of the new smell to the person where neural receptors cells that initially fire strongly as the new stimulus is detected. Now, to the touch or the tactile adaptation, the feeling of a watch on your wrist or the clothes on our skin is initially noticeable, but the sensation quickly fades as your touch receptors adapt to the constant pressure. Like, for example, when we wear certain jewelry in the neck or small kind of classic top in our ear, for the first time we might feel the pressure, but with time there is the adaptation, and that adaptation is tactile adaptation. Temperature. So when we step in a hot shower, the water initially feels extremely hot, but within moments it feels comfortably warm as our thermoreceptors adjust. Same happened with the hearing. People who live near train tracks or busy highways eventually stop consciously noticing the noise of passing trains or traffic. Sometimes we visit to very noisy place, right? And whenever we see those people, we feel like how they are being able to sit at that place, live at that place. But it is because of the auditory adaptation. Those people living nearby consciously notices the noise passing, or they are already auditorily adapted. But there is exception of the vision. Vision is a common exception to simple sensory adaptation. While eyes do adapt to overall light levels, example dark adaptation while entering a dim room, vision generally does not fade away like a constant smell or touch. Why this happens? Because it is due to a tiny, constant, and involuntary eye movements like saccadic movements or microsaccades. These movements constantly shift visual stimulus across retina, ensuring that the sensory receptors are never exposed to a truly constant, unchanging image, thus preventing the visual image from disappearing. If we will have this visual adaptation, it might be problem because we cannot we cannot be irresponsive to the images we see. For example, if a mother talks to us, we will notice her, right? Because if we don't notice us or no, don't notice her, or we don't feel like she's not there, what will happen? It seems abnormal. The good thing about that is there is this tiny constant involuntary eye movement called saccadic movements or microsaccades, which helps us from preventing the visual image from disappearing. For references, you can go through the following references, and if you want to know more about sensory adaptation, please go through these articles. Thank you so much for watching this video. If you like this video, like and subscribe to the channel. Thank you so much.